So again, we know that those arrays are one way that we can show groups of things easily organized. Sometimes for multiplication, we start messing with really large numbers, and that doesn't become the best strategy. Can it still work? Yeah. It's just not as efficient. It's a little bit slower than we want it to be. So we can use a fast array, which is when we draw just the first row and just the first column. So we're going to draw an example in our notebook. Go ahead and write 5 times 9 in your notebook. 5 times 9 would be a lot of dots. 5 groups of 9 dots. That's a lot of dots. Instead of drawing a full array, because that would take a little bit, we're going to do a fast array. We're going to do a fast array. The way that we're going to do a fast array is we're going to draw our 5 groups going down. 1, 2, 3, 4, 5. There's my 5 groups. And then I'm going to have 9, my 9 that are going inside each group, going across. Don't forget to count this guy. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm done.
Really?
Really, that's my whole array.
Okay, now what are you going to do?
Now, does that mean that the dots that I didn't draw, those don't exist? Is that what that means?
No.
No. You guys are good enough at arrays now that you can look at that and imagine the rest of the dots that go here and here and here and here. You don't need to draw them. You can go ahead and put them in your brain. Does that make sense? Now, how could you use this to help? Well, we can still skip count. I like to karate chop when I do my fast arrays. And what I mean by that is every group of 5, since I have a 5 right here, and I'm good at skip counting, I karate chop so that I remember, oh yeah, there's 5. So I might say karate chop 5, 10, 15, 20. Oops, I deleted that one. 25, 30, 35, 40, 45. I'm karate chopping right on top of those 9 on the top. It helps me keep organized, and it helps me count without having to draw every single dot. Does that make sense what we're doing? Yeah, a little bit faster than a regular array. Cleverly named a fast array. Alright, let's try a few more. I want you to do a 5 by 7 in your notebook. Write the equation 5 by 7. Make the fast array and use those karate chops to figure out what is 5 groups of 7 worth. Alright, so again, our 5s are usually pretty easy for us to skip count. Trick question. What is 5 times 0? Tricky, 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 tricky. Tricky. What? Victor, you think you know?
I'm pretty sure 0 and 5.
Is it 0 or is it 5? Those are 2 different things. 0 groups of 5. Remember when I gave you 0 pencil rules? Is 0 a 0 on our 100 chart?
Nope.
Nope. Let's scoot over to one group of 5. What is one group of 5 worth? Shelby? 5. 5. What comes next? Elena? 10. Shout it out. What's next?
15.
15. What's next?
20.
20.
25.
Keep going.
30.
Keep going.
30.
40, 35, 40, 45, 50, 65, 65, 80, I'm not saying anything.
Alright, after 100. We're not skipping beyond 100 on our 100 chart, but what would be that next number if we were to continue skip? Michael? 105. Very good.
It'll be the same, but you're.
What are we noticing in our 100 chart? When we skip counted by 5, we have some pretty distinct patterns. Distinct meaning like obvious. What's a pattern you see? Okay, so it goes straight down. Where? Where is it going straight down in our 100 chart? When we count by 5. Okay. What else do you notice in that 100 chart? There's some pretty unique things. Jackson, what are you noticing?
That it's not starting with the one.
Yeah. Look very carefully at those ones. Look at the ones place in all of those numbers. Wait, what do you notice?
I know that the starting numbers odd, but the second number is even.
So our number, our digit in the ones place is 2 options. When you skip count by 5, that number either needs to end in a 5 or a 0. Look at your 100 chart. All those numbers you colored in either have a 5 in the ones place or a 0 in the ones place. Let's write that down somewhere above or below your 100 chart.
Off the chart?
Yep, that's fine.
Are you right?
All products, that means all the answers when we're skip counting, have either a 5 or a 0 in the ones place. All products, I know that was really hard to see, I'll put it back in black in a second. All products have either a 5 or a 0 in the ones place. Yeah. So that means if you're multiplying and all of a sudden you get the answer that ends in a 7, did you do that multiplication question right? No, I don't even care what your number is. It's 100% not right because I know all my 5s end in either a 5 or a 0. Never, ever, ever will it end in a 7.
Or
ever. Or 6. Or 4. Or 2. Or 1. Never. Crazy, huh?
No. And that's the same with other numbers.
That is the same with other numbers, right? When I multiply by 2, it's not going to end in a 1. Or a 3.
Or 10.
10 ends in a 0. So it will. Alright, we are going to go ahead and enter in our multiplication chart because I knew that you guys could quickly figure out our 5s. So go ahead and turn to your mini multiplication chart. Elena, Braden, and Tinley, give me some seconds. And okay, read your new one. We are turning to the one that looks like one finger on one factor at the top, one finger on one factor from the side, and then I'm going to drag them to where they meet. And where I meet is my product for my answer, that multiplication fact. Victor, turn back to this, please. It should be dog-eared. Find where you dog-eared it in your notebook. All right, we'll go find it. All right, we're back on black. Good. All right, so let's start with 5 on the top times 0. What is 5 times 0?
0.
0. You already have it filled in. What about 5 times 1?
5.
5. You already have that filled in. What about 5 times 2?
10.
10. You already have that filled in. What about 5 times 3?
15.
15. Let's fill that in. What's going to be next? 5 times
20.
4?
20.
20. 5 times 5.
25.
5 times 6.
30.
5 times 7.
35.
5 times 8.
40.
5 times 9.
45.
5 times 10.
50.
50. 50. Even up. Is there anything else I can fill out on this chart? Is there anything else? Is that it? Is that all I can do? Okay.
Nope, you can fill out.
Will?
I just mine ends in a in 55.
Well, then you missed something.
It's about 40. 35, 40. Oh,
There you go. Is there anything else I can fill out? John?
Yes, on the bottom row, because you have to do communicative properly.
Yes. Go grab a piece of big candy. Why? One, who's paying attention. 2, I can go across. I can change those factors around and my product is not going to change. Right behind it. Big black box. 1, please. So yes, I did do 5 times 0, but now I can go the other way. Now I'm going to put a 0 up top and a 5 on the side. 0 times 5. What is 0 times 5? 0. What about 1 times 5? 2 times 5? 3 times 5? 15. I can fill that in. 4 times 5? 20. 5 times 5?
25.
25 is already filled in. 6 times 5?
30.
7 times 5?
35.
8 times 5?
40.
9 times 5? 10 times 5?
50.
Very good. Whoa, check out all the multiplication facts that you already know. It is kind of fun. We know strategies to fill out every single one of those. That's awesome. These are going to be complete arrays, full arrays, no fast arrays, please. I want a 5 by 2 in yellow only, and then another 5 by 2 in red only. So you're going to have 2 arrays on your desk. Put your mouse up, Sean. That should not be out. So again, you're going to create a 5 by 2 in yellow only, and then a 5 by 2 in red only. Go ahead and do that now, please. So yeah, just like what Michael said, this is just like our doubles. Just like what we do with 2s and 4s. If you know your 2s, you can double it to get to your 4s. If you know your 5s, you can double it to get to your 10s. It's going to be the same thing. So let's go ahead and put our counters completely away. Counters go back in the math kit. If you want to erase your desk from your whiteboard marker, that's fine. Make sure all counters are not on the floor. Put our counters back away. Put our whiteboard markers back away. Get your math notebook out on your desk again. We're going to be looking at that hundreds chart, but this time we're going to be coloring in blue. Chart, the same one we just colored in for our 5s. We're going to be coloring in our 10s now. Trick question, 10 times 0. 10 times 0, Lincoln. 0 is 0 on our 100 chart. No, but we can start with 10 times 1. What is 10 times 1, Victor? Nope. 10, very good. Color in that 10. It should probably turn green because now we've mixed yellow and blue. What's going to come next? 10 times 2. What's 10 times 2?
20.
Victor's the only one that knows. 10 times 2?
Oh.
Thanks. Bella, 10 times 2? 20. What comes next? Hello, what comes next? 30. What comes next?
40.
What are we noticing now that we've done our tens? What's something that we're noticing now that we've done our tens?
They all answer.
Lincoln, what's something that you noticed? Whoa! Did you just hear that? That was brilliant. Say that one more time, Lincoln. Yeah, in that one place, that digit that is in the ones place, it's always 0. That means if it is 10 times 8,167, and you tell me that the answer ends in a 7, are you going to be right?
No.
No. Isn't that crazy? You don't even have to know what the answer is, but if it's not ending in a 0, it's not going to be correct. Crazy. Let's write that down
Has to end with
somewhere on our hundreds chart. Let me see if I can go back to my 10 section. So we have that all of our products
Where are we writing that?
somewhere on that hundreds chart, either top or bottom, all of our products of 10 have a 0 in the ones place. It's a better color than yellow. You can see that a little bit better. Yes. All of our products of 10 have a 0 in the one place. Why? Why do we think that is? Why do you think that is? Why did it always end in a 0? Any ideas? What do you think, Bella? Because we're counting by 10, sure. Any other ideas as to why they all end in a 0? Shelby, what do you think?
I think I might have one.
Yeah, because our 10s when we skip count always end in a 0. Devin, what do you think?
I think because if we had no zeros, it'll just turn into just a regular number, like 1 or 2.
Sure. Okay. What are we noticing about the relationship between 5s and 10s? How are they related? 5s and 10s, how are they related? Jackson, what do you think? They don't all have zeros. Remember, our 5s can end in our 5s too. They don't always go by 10s. 5s don't go by 10s. Gwen, what do you think? How are those 5s and 10s related? Okay, no worries. Lincoln, what do you think, Ed?
So when you count by 5, 10 is in it too.
Yeah. Yeah. Sean, you want to add on to that?
5, 5.
Ooh, can you explain that relationship? You're exactly on the right track.
So 5 plus 5, and if you're doing 5, and then when you're counting by 5, instead of doing 5, 1, 2, 6, 7, 8, 9, 10, you're doing 5, and then you're just adding another 5 in your head, and then you're skipping straight to 10.
Bladen, what do you think?
Whenever you're counting by 5, you'll get to 10 whenever you're counting by 5, but also, when you're counting by 10, it goes to 20. When you're counting by 5, you can also get your 20 by counting by 5, so higher numbers than 10.
Awesome. Jackson?
Like if you have a problem like 5 plus 5 plus 5 plus 5 plus 5, you can go and 5 plus 5 plus 5, you can add 2, 5, and make it to 10.
Love that.
And then you can combine together to make it 20.
Brilliant. Jackson's saying we can combine our 5s to get our 10s because our 5s can be doubled to make our 10s. That works. Just like our 2s can be doubled to our 4s, our 5s can be doubled to our 10s. Let's go fill in our multiplication chart. Turn back to that multiplication chart. Let me go way back. Whoa, way back, way back, way back. Here we are. fill out our tens. Put one finger on that 10 at the top. I need that song in our head. One finger on the 10. One finger on the 0. What is 10 times 0?
0.
0. Already have that filled in. What about 10 times 1? Already have that filled in. 10 times 2? Already have that filled in. 10 times 3? 30. Fill it in. 10 times 4? 40. Fill it in. 10 times 5?
We already have it.
We already have that one. 10 times 6?
60. No, 30.
10 times 7?
70. Last one's 100.
10 times 8?
80.
10 times 9?
90.
10 times 10?
100.
Is there anything else I can fill out on this 100 chart? Is there anything else I can fill out on this 100 chart, Gwen?
Fill out the bottom.
Why?
Because it follows the same pattern, and you can see from what's down there. Like, it's 0, 10, 20 down there, but you're not supposed to have 50. So it'll be like 30 and 40 and 50 and 50.
So I don't have to have my factors in one specific order. I can switch them. Is that what you're saying? Yes!
You can go back.
What is that special rule called where I can switch them, Gwen? Do you remember? She doesn't remember, but you know what she's doing? Looking in her notebook of knowledge. That's a brilliant strategy.
I have to say it's commutative property.
Commutative property. Grab a big piece of candy. Thank you, Gwen. Let's fill out that bottom. We have 0, 10, 20. What's coming next?
30.
What's coming next?
40.
What's coming next?
We have it.
We have 50. Let's keep going. 60,
70.
70, 80,
90.
90,
We already have 100. Not a lot is done.
We have a lot done. You guys know a lot of multiplication facts.
And community. And like we literally just started.
I know, it's wild. It is wild. All right, we got a few more things to do. Go back to the last page that we were just working on with our tens. Go back to the last page you're just working on. It's probably going to be a new page because I think we have our hundreds chart on there. I want you to title it Dividing by Tens or Fives.
Next page.
Yep, next blank page right here. Dividing by tens or fives. Go ahead and make that your title. Alright, so we're going to be dealing with, when we're dividing, some really large wholes. Some really large amounts of things. We know one strategy for dividing. I can start giving everybody 1, 1, 1, 1, and keep going until I run out. We know that is the dealing out strategy. But sometimes, if I'm starting with a really big number,
That'll take a while.
that'll take a long time. So let's start looking at some other strategies that might go a little faster. And one of those is using our multiplication facts. So I want you to write down this equation. It says 60, this slash, remember I can't do the division sign on my computer, is divided by 60 divided by 6 equals box or question mark. Go ahead and write that equation down. If I was using dealing out, I would have to get 60 things, make 6 groups, and then start putting 1 for you, 1 for you, 1 for you. That I could do it. It would just take a long time. So what I'm going to do is I'm going to use what I know about part whole to help me solve this. Out of those numbers, out of 60 divided by 6 equals box, which one of those numbers is the whole? Which one is the whole, Michael? 60 is my whole. Put a little W above 60. Which one of those is my part? Lincoln? 6 is one of my parts. Yep. What's the other part? Show me. Yeah, box. When I am multiplying, do I start with the whole thing, or do I start with only a part of it?
Part.
Part. Pick a part. Which part you want to start with? Wait a 6. All right. Right. 6 underneath that. Put a little p. We're going to start with our p. Question? Question? Okay. We're going on to our next part. Victor, what's our next part going to be? What's our next part going to be? We got one of our parts, which is 6. What's our next part?
I was gonna answer the top.
Oh, we're not solving it yet. So if you got the answer, hang on to it. Do you know what our next part is? So we have labeled our parts and our holes up here. We've already used this part. What's our other part? Something? Nope, that one has a W. That one's for hole. It's not a number at all, which makes it extra tricky. It's box. You see where I put that P above box? It's actually box. Isn't that crazy? Something. Here's my other part. Equals 60. And then I need my whole, my total. Because when I multiply, I get my total amount of things. Jackson, what is my whole? 60. When I see this equation, can I figure that out?
Yeah.
6 times something is 60. Do you know what that would be? 6 times something is 60. Do you know that one? Lincoln? What is that? 6. 6 times 6? It's not going to be 6 times 6. Nope. 10. 10? All right, let's try. Ready? 10, 20, 30, 40, 50, 60.
Yeah.
Yeah, 6 tens. 6 tens. 6 tens got us to 60. Was that a little faster than dealing out?
Yeah. A lot.
Could you have dealed out?
Yeah.
Yeah, you could have. You
It
could
would
have.
take a lot.
This is just a different way to think about it.
Take about 5 minutes to say.
I have another question. What does it do with this?
Or 6.
What's that? Go ahead and write 45 divided by 5 equals 5. That's our second equation. We're going to try this new strategy out. Which one of those is my whole? Which one of those is my total? Bella? 45. Put a little W above it. Which one of those is my part? Elena? 5 is the part. Henley, what's my other part? Box.
Like, if you draw that, division side? Okay.
Now I'm going to flip this equation using my part whole to figure out a multiplication equation. So I'm going to start with a part. What's one of my parts that I could start with? I can do either one. It doesn't matter. Gwen, what do you want to start with?
Start with box.
Go for it. Box. Times. What's my other part, Shelby? 5. Very good. Equals my whole. What is my whole?
1 box.
Something times 5 equals 45. Skip count by those 5s and figure it out. Something times 5 equals 45. Will, you with me? Okay, making sure. Ready?
No.
9. Was that a little faster than dealing out?
Yeah, it would have, we would
Yeah.
probably...
You could have done it, and it would have been fine, and you would have gotten the right answer. But sometimes it's a little easier for my brain, especially if I'm using things that I'm good at skip counting with, to figure it out from multiplication instead of dealing out. Because I know how to skip count by 5 like super fast. That messing with her. You can speed it up over so you're not in your face. That's fine. She's good at math. Okay, well, let's solve this. You guys can spread your desks apart so you got a little bit more space.